Hello, students. Today we'll be working on doing the derivative of a function within a function. And sometimes you might see that as y equals f of g of x, so a composite function. Or more likely, you'll see it as a parentheses with a power, or maybe a trig function where the angle is more than just an x. And so the chain rule is going to be described in the following way. We would have for a composite function y equals f of g of x, the derivative y prime equaling, we'll do the outer derivative first, so f prime of, and we'll keep the g of x the same, and then we'll multiply by the derivative of the inner function, and so multiply by g prime of x. So unlike most mathematical operations where you work from the inside out, with the chain rule, you work from the outside in. If your function is stated as a power, then the derivative would be using the power rule. Y prime, we would bring the power in front, keep the function intact, so not make any changes to the inside. So n times u of x to the n minus 1 power, and then we'll multiply by the derivative of that inner function, so times u prime of x. So we'll see in this, we only have 4 examples. This is a fairly short lesson, but a very important one that we will use for our derivative problems for the rest of the semester and into next semester. So we have y equals 6x minus 5 in a quantity to the 4th power, and to avoid having to do the chain rule, we could multiply out 6x minus 5 times itself 4 times, creating individual terms that we could just use the power rule on. But I actually think that doing the chain rule is a little bit quicker and easier. So on this problem, we'll have y prime equals, we'll bring the 4 in front of the 6x minus 5. We'll keep that 6x minus 5 as it is. Reduce your exponent by 1, so we'll take it to the 3rd power, and then we'll multiply by the derivative of inside the parentheses. So the derivative of 6x minus 5 would just be a 6. And then we can simplify this as y prime equals, you can multiply the 4 and the 6 together, 24 times, and then 6x minus 5 to the 3rd power. And there would not be any reason to multiply out the 6x minus 5. All right, so that's using the power rule, remembering that you work from the outside to the inside on these. I'm going to clear the screen, and we will move on to your next example. So this one is one that often is mistaken as not needing any kind of chain rule, but because the angle is not just an x, we have to apply the chain rule, and this is the way it would work. Y prime will equal the derivative of tangent, which is the secant squared of the angle that you started with. So the angle we started with was pi x plus 1. So you do the derivative of that outer function, keeping the angle, and then you multiply by the derivative of the angle. The derivative of pi x plus 1 is pi. So we would multiply by pi. Oftentimes, whatever that part of the derivative is brought in front of the trig function. Be sure that you keep your angle in a parentheses and don't separate it from the trig function. So that would be the chain rule used on a trig function. If you'll turn your papers over, we'll look at two other problems that utilize the chain rule. One of them we'll need to do a rewrite first. So on problem 3, we need to get the square root as an exponent. We also need to get it out of the denominator. So we'll write this as y equals x plus 1. To get it out of the denominator, I'll need a negative exponent. And to get it out of the square root, I'll need to use that 1/2 power. So y equals x plus 1 to the negative 1/2 power. So we can do the chain rule to do the derivative. Y prime, we'll bring the negative 1/2 in front. Keep the parentheses. Reduce your exponent by 1. So negative 1/2 minus 1 would be negative 3/2. And then multiply by the derivative of the x plus 1, which is just a 1. But I think it's a good habit to write that. And then as you're simplifying it, you could put the negative 1 in the numerator. In your denominator, have the 2 and the x plus 1. When you're moving it to the denominator, you'd use a positive exponent of 3/2. You could switch that back to a radical if there was something that you needed to simplify using a radical. So all of those would be equivalent forms. So sometimes you still do have to rewrite and then do your derivative. And then finally, we have number 4. So I'll clear out number 3 and scroll on up for our last example. And on problem 4, you have a power. So once again, we could multiply this out, but even then, you've probably got a fraction to deal with. So really, there is no rewrite. We simply just need to start right in, and we can apply the chain rule. So we'll bring the power 3 in front. We'll keep the inside 1 minus 2v over 1 plus v, and reduce your exponent by 1. So that'll be an exponent of 2. Now, when we multiply by the derivative of the inside, hopefully you're thinking, well, that's a quotient, and it is. So we're going to have to do the quotient rule. So this is a multiplication. So it's on that same line. It may seem like a second part, but this is all one line. So you're doing Hody high. So that would be 1 plus v times the derivative of the numerator, which is negative 2, and then minus Heidi ho. So 1 minus 2v times the derivative of the denominator, which is just a 1, and then over, remember it's ho-ho on the bottom. So 1 plus v to the second power. All right, so we'll continue to simplify. I think one thing that is going to help, just because I can see the denominator has 1 plus v squared where I've written that in red, I'm going to go ahead and make this 2 quantities to the second power. That's a way that you can equivalently write the 1 expression to the second power. And then in the red part, I can distribute the -2. So -2 minus 2v. I can distribute the -1. So -1 plus 2v. And then my denominator, 1 plus v to the second power. And I'll just do a rewrite for right now of the beginning part. But I do have some like terms that I can combine for what I've written in red. So the numerator, the -2v and the +2v will cancel. I'll have -3 in the denominator, 1 plus v to the second. And so finally, I'll put everything all as one fraction. I can multiply my 3 and my -3, making -9. My numerator, 1 minus 2v in parentheses to the second power. And that -9 can be in the numerator with that. And then I have 1 plus v. Adding my exponents, I would have to the fourth power. And that is the derivative f prime of v. So here was an example of having a rule like quotient, or we could have had product within the chain rule. And that's where you can see that it did get a little bit more complicated. So recognition of the chain rule will be something that you'll have to work on. And then remembering that you have all the other rules still applying, particularly the product rule and the chain rule. So this was, again, a short lesson, and please don't confuse the shortness of it for not being important. It is an important lesson and one that we'll use quite a bit. So good luck on your homework.